Today we are discussing Chapter 5, Describing Distributions Numerically. The median and the IQR are used together and are appropriate for most data sets, unless the data is highly multimodal. Median is the middle value of the data and is also denoted as Q2. Maximum is the highest value. Minimum is the lowest value. Range is the difference between the maximum and the minimum values. Lower quartile is the middle value of the lower half of the data, denoted with Q1. Upper quartile is the middle value of the higher half of data, denoted with Q3. Interquartile range, IQR, is the range of the middle half of the data, also Q3 minus Q1. IQR is Q3 minus Q1, like I just said. Five-number summary. It's the minimum, Q1, median, Q3, and maximum. A box plot displays the five-number summary graphically. This is an example of a box plot. Here we have the minimum value, Q1, the median, Q2, Q3, and the maximum value. Each range of data is 25% of the data, and the box is the middle 50% of the data. Outliers are isolated data values that are more than 1.5 times the IQR away from the middle 50%. They are often represented with asterisks beyond the whiskers, and the whiskers extend only to the furthest data value that is less than 1.5 times the IQR from the box. So this would be an example. Here I have Q1, IQR, and Q3. These would be examples of outliers because this is 1.5 times the IQR. The mean and the standard deviation are appropriate for symmetric unimodal data sets that have no outliers. When appropriate, these measures of center and spread are more accurate because every data value is used to calculate them. The mean is the arithmetic average. It is the balance point of the data, much like the fulcrum of a seesaw. Y bar is the sum of all data values divided by the number of data values. The deviation is how far the data value is from the mean, y minus y bar. Variance is the sum of the squares of the deviation divided by n minus 1. Standard deviation is the square root of the variance. Let's look at this example. Find the standard deviation of the following heights in inches: 67, 72, 76, 76, and 84. So if we were to show this by hand, you would do it as follows. If you would like to pause the video and try it on your own, feel free to go ahead. So first, we would list our data values y, 67, 72, 76, 76, and 84. Add those together to get 375. So our sums will be at the bottom. N is 5. Y bar would be 375 divided by 5, which equals 75. And now to find our standard deviation, we first need to find y minus y bar, and that would be -8, -3, 1, 1, and 9, and you should get 0 as your sum. And then we need to find y minus y bar squared. We'd have 64, 9, 1, 1, 81. Add that together, you get 156. So our standard deviation would be the square root of 156 divided by n minus 1, which is 4. That would give me the square root of 39, which is about 6.245. And this would be if you had to show it by hand. You can also use your calculator to find this.